Well, hello everyone. Welcome to my channel. Today we have here an IRODOV problem. Take your time, pause the video and read the question. After that, we'll get solving. A cylinder rolls without slipping. It reaches the point O and turns about that point, making all the points on the cylinder act under free fall during this period. Here, the angle beta cannot be greater than the angle alpha, as the cylinder would jump otherwise. The difference in the heights of the cylinder at point O and initially is r minus r cos beta. That is r 1 minus cos beta. So the difference in potential energy is delta P equals mg delta H, which is equal to mg r 1 minus cos beta. The difference in kinetic energy would be half moment of inertia v center of mass squared by r squared minus half I v naught squared by r squared. This is delta K. So according to the law of conservation of energy, delta P equals delta K. We can write mgr 1 minus cos beta equals 1 by 2 I by r squared v center of mass squared minus v naught squared. And this is our first equation. Now, using Newton's laws of motion, we can write m v center of mass square divided by r equals mg cos beta minus n. Further, we can write v center of mass square equals rg cos beta minus nr by m. Using parallel projection for moment of inertia from the center of mass to the point O, we have I equals 1 by 2 mr square plus mr square, which is 3 by 2 mr square. As the problem says no slipping, therefore we immediately realize that the moment of inertia should be taken from the contact point between the cylinder and the surface. This is equation 2. Solving 1 and putting the value for moment of inertia, we have mgr 1 minus cos beta equals 1 by 2 3 by 2 mr square divided by r square v center of mass square minus v naught square. Solving this, we get, and this is equation number 3. Now plugging the value of v center of mass squared from equation 2 into equation number 3, we get v naught square plus 4gr divided by 3 1 minus cos beta equals rg cos beta minus n r by m. Solving this, we get v naught square plus 4rg by 3 minus 4rg cos beta by 3 minus rg cos beta plus nr by m equal to 0. Further solving it, we get v naught square plus 4 by 3 rg minus 7 by 3 rg cos beta plus nr by m, which is equal to 0. Now we can write this as v naught square plus rg by 3 4 minus 7 cos beta plus nr by m, which can be further written as v naught square equal to 7 cos beta minus 4 Rg by 3 minus nr by m. We know beta can never be greater than alpha. Therefore, we can write beta to be equal to alpha. And we can rewrite this equation number 4, into v naught square equals Rg by 3 7 cos alpha minus 4 minus nr by m. For v naught to be maximum, you have to let this term to be equal to 0. Therefore, we have v naught max equals root over 1 by 3 gr 7 cos alpha minus 4. And this, my friend, is our answer.